So, what are the economic impacts of climate change and how were they estimated? I'm going to show this graph quite a lot, so let me tell you what it shows. And on the horizontal axis, we're looking at the change in the global mean surface air temperature. This does not mean that we believe that the global mean surface air temperature is the only thing that matters. This really stands for changes in the pattern of temperatures across the globe. It also includes changes in rainfall, changes in wind, and so on and so forth. This is just an index of the severity of climate change. And the further to the right you are, the more severe climate change becomes. On the vertical axis, we're looking at the welfare equivalent income change, or the HCM equivalent variation. It's a bit of a mouthful. Essentially what that means that if the world were to warm by 2.5 degrees, then the average person on the planet would feel as if she had lost 1.3% of her income. It does not mean that the average person has lost 1.3% of her income, but she feels as if she had lost 1.3% of her income. So that is how you should read the graph. The blue dots are the population of the published estimates of the economic impact of climate change, and then the red lines are a curve fitted through it. So the first question you may have is, where do the blue dots come from? How were these estimated? Well, people have used a range of methods, and the first method is the most popular and the oldest is the so-called enumerative method, and that was designed by Ralph Darts back in the 1970s, in fact. And essentially what you do in this method is you quantify the impacts of climate change in its physical terms, or in its biological terms, or in its health terms. So you calculate the amount of land that would be lost due to sea level rise, you calculate the change in wheat yields, you calculate the number of people prematurely dying because of climate change, you estimate all these things in their natural units, then you estimate the price of this, or the value of this, which is sometimes easy. If you're talking about dikes being built, then it is a question of what would it cost to build those dikes, and sometimes it's much more complicated. If you're talking about species going extinct, then you actually need the monetary valuation methods that we talked about before. So you estimate the quantity, you estimate the price, you do that for every impact separately, you multiply price and impact, and then you add the whole thing up. Now this is obviously a simple method. Essentially you estimate the direct costs, don't even take into account that if quantities change then prices may change as well, nothing of the sort. It's a simple method. You also do not take into account that if perhaps water resources change, then that would have an effect on agriculture. No, you estimate things separately. That is what you do in this method. It is imperfect, but it gives you sort of a crude first approximation of the welfare impact. And this is the most popular method. This is actually what most of the studies in the literature have done. Other studies are economically more sophisticated. Essentially, the starting point is the same set of physical impact estimates, but they are not just multiplied with a price, but they are instead fed into a computable general equilibrium model, a model of all the markets and all the international markets in the world, both output markets but also input markets. So you quantify the impact and you shock the model. So, for instance, changes in agriculture are changes to the productivity of agriculture in a general equilibrium model, or land loss because of climate change is a change in a resource in the economy, and that simply disappears. So you use these physical impacts and shock the model, as it's technically called, and then you estimate the welfare change trickling through all the different markets, both national markets and international markets. The good thing about this method is that it's consistent. It takes into account partial equilibrium effects and general equilibrium effects. The welfare impact, welfare estimate that you get is a proper welfare estimate. It's the HCM equivalent variation rather than just a direct cost estimate. So that has all sorts of advantages. It also includes interactions between impacts as well as international interactions. For instance, if a lot of lands get lost due to sea level rise, most of that is agricultural land, which lead to a loss in the places that suffer this, but of course it improves the comparative advantage of countries that do not suffer these losses. So all these things pop up, so that is all quite nice. The main disadvantage of this method is that computable general equilibrium models are based on the national accounts. And that means that anything that is not in the national accounts is not in the computable general equilibrium model, so it's necessarily an incomplete estimate. And that includes such things as biodiversity loss, simply not in the CGE, but it also leads to incomplete estimates of the health impacts of climate change. Because what is in the national accounts is you going to the doctor and getting a prescription. That is an economic transaction. But what is not in the national accounts is you feeling ill. So it is necessarily an incomplete estimate, but more satisfying for the market impact of climate change, much less for the non-market impact of climate change. So this is what a number of studies have done. There's one study where an elicitation method was used. That is, essentially experts were asked, what do you think is the economic impact of climate change? Nothing wrong with this method. The problem at the time of that this study was done, nobody could genuinely call themselves an expert on these matters. But there is one study that just did essentially a contingent valuation study. What do you think is the impact of climate change? And then there's a number of studies that use a statistical method, or the so-called Ricardian method. And essentially what you do there is you estimate an empirical relationship between an economic activity and climate. And you measure that over space, and then you assume that the same relationship holds over time. And this was first done for agriculture, and it's called the Ricardian method because it was David Ricardo who first realized that if you buy a plot of land, you do not just buy the soil, but you also buy all the sun that will shine on that land and all the rain that will fall on that land. And those things are incorporated in the price, because you would be willing to pay more for a piece of land that sits in a favorable climate than sits in an unfavorable climate. So that is why it's referred to as the Ricardian method. The good thing about these statistical methods is that you do not need to make assumptions about how people will respond to climate change. The enumerative methods and computable general equilibrium methods are based on physical models or biological models or medical models, and they make assumptions about how people respond to climate change. In the Ricardian method, you don't make those assumptions. You measure how people in the past have responded to climate change. So that is its main strength. You don't make assumptions about adaptation, but you measure adaptation. The main weakness of this method is that you estimate a relationship over space, where climate varies quite a bit, and you assume that that relationship holds over time. And there's two main problems with that. One is that the relationship that we estimate over space has a lot of trade in it. So if you run a regression of, if you look at agriculture in the US, what people are doing is that if you look at Maine, it's pretty cold, people grow a lot of wheat, a lot of fishing as well. Whereas if you look at Florida, people grow a lot of citrus fruit, because the climate is very, very suitable for that. And citrus is much more valuable than wheat, and therefore you find that people are prepared to pay more for a piece of agricultural land in Florida than they are in Maine. And then you estimate this relationship, and you find this nice relationship with climate. Actually, it shows that warmer is better, and then you extrapolate it over time. But essentially what you then assume is that you see more and more citrus production in the future because that is more valuable. So there's no sense whatsoever. There's actually demand for all this citrus fruit and all this orange juice. So the demand side is typically neglected here. but also what allows people in Florida to grow citrus fruit and the people in Maine to grow wheat is not that people in Florida drink a lot of orange juice and people in Maine only eat bread. No, there's trucks going up and down the Atlantic coast all the time to bring the wheat from Maine to Florida and the oranges from Florida to Maine. So that is implicit in your estimate of the impact of climate on agricultural activity over space. But over time, that relationship breaks down because we travel through time in one direction at a constant speed. You can't send trucks back and forth through time. So that is one main drawback. The second, if you measure things over space, and definitely if you measure the impact of climate on agriculture within a country, say the United States, you, at one point in time, you hold institutions constant, you hold international trade policy constant, you hold technology constant, and all those things do not only affect the level of economic output, but also its distribution over space. So those are the two key drawbacks of the Ricardian method. It's not just been applied to agricultural activity, but also to energy, to total consumption, and even to self-reported well-being. So those are the methods that have been used. You can quibble with each and every one of these methods, but this is what's been used, and this is what these studies have found.